So now that our desktop is up and running, let's take a look at implementing the server. So SUSE server, let's say this is the network installation. So we'll use HTTP. So let's say via HTTP server. The current instance is a Debian instance, Ubuntu to be specific. So we'll ensure the ISO image is there. It's already in place. We'll mount it, share it as we typically do, and then reference it during installation. So tasks, ensure SLES12 ISO image is HTTP accessible. That's the first step. Now, we have a system that we use all the time. That's 75101, which runs Ubuntu with obviously HTTPD or Apache, so we can work with that. Let's get an SSH instance going to that node 75101. First time in, so we'll take the key. It's using ECDSA, elliptical curve DSA. And now this is expecting that we have the PKI set up. So let's SSH without root and then SUN. And then we'll navigate into the publish area, which is /linuxcbt. Now in this directory, we've got the ISO image. This is SLES12 DVD. And this you can download. Of course, confirm the checksum, so run a SHA against it. We've already done that. We're going to mount it as an ISO 9660 loop device into a directory that's already determined, SUSE12. And that should be in place. Let's take a look here, SUSE12. Indeed, it's mounted. So in SUSE12, we should see the full tree. And this can be used to install the operating system. So that's in place. And for us, that was simply cd into linuxcbt. Follow that up with a mount type ISO 9660 loop device. The location to the loop device, which for us was or is linuxcbt, and *ISO. This is what you'll pull from the SUSE site, or if using OpenSUSE, whatever the name of your ISO image is, that's what will be reflected. And we mounted that in a place that we will reference during installation. So now that that's mounted, of course we confirm it, DFH confirm mount, and take a look at the directory. Now that that's in place, we need to set up. So let's say VMware ESXi setup guess. So we need to provision a guess. Typical specs, so 1024 MB, 20 GB storage, 1 CPU, 1 NIC, etc. That should suffice for us. And we'll use Linux 64-bit. So this will be our profile. And once it boots with the ISO image, of course, reference SLES ISO image. Now the ISO image has already been copied to the ESXi instance. So it's just a matter of mapping it. Let's save the changes here. Now let's take a look over on that node. Our manager is this front-end Win instance, which has the vSphere client. So for that reason, we keep it running, as the client is not, at least not yet available for Linux. We'll wait for this to come up. Let's see what this is doing. It's a bit slow because we have both instances going, along with other software. And this should signal the client's availability. Let's just get rid of this. And there it's finally come up. Let's make some space in the interface. So in here we want to add a new instance, new virtual machine that is. Let's customize it. Let's call this Linux CBT SUSE 1. And here are different types. So in terms of the appropriate Linux type, let's go to Linux. So they're all types. You just want basically Linux 64-bit. SUSE is even closer, so we'll go with 11 64-bit. That looks good, a gig. This needs to be on the standard virtual network. Let's make this 20 gigs. And we still want to, of course, modify it. We tend to make the same changes. We could simply copy one of the existing config files and mark it up from the shell, but the GUI makes it more intuitive, more interesting, at least visually. So let's get this ISO image out of the SLES directory. So in our data store, we have an OS or distribution or ISO image repository for different operating systems, which will reference SLES. And this is the same. Actually, we have both images. We brought both of them in, but we'll go with the first ISO image in the event that we needed additional items, such as source packages and so on. Let's make sure this is connected at power on. That looks good. So the settings look like they're in place, so we should be able to fire this up. Let's navigate to the console and make the changes. So there's the fire up we expect. So to install from the network, now notice the sources are listed, or the source option is accessible via F4 and it defaults to DVD. So that needs to be shifted to the network source. So let's go ahead and tell it to use the network. In this case, HTTP 75.101. And the default directory /SUSE. That Linux CBT directory is the root for that particular website, 192.168.75.101. So we'll just simply reference the directory SUSE12. And it should be able to find it from there. In terms of video mode, we'll go with the default, which should fit within this window. But if there are any concerns, you can always switch it to something appropriate. And that's the F3 option, obviously. So F3 allows you to change accordingly. Actually, we hit F2, but F3 allows you to change resolution accordingly. So this looks good. Let's proceed with the installation. Maybe we'll free up some of the resources here. Screen resources, we mean screen navigation. So just get a little more real estate. The width is not so much the issue, it's usually the height. Tell it to retry. Sometimes the first time the attempt to access the media fails because the network driver probably hasn't fully loaded, or in some cases the back-end disk that backs or stores the contents of the ISO image may not be ready. In our case, we're using a SATA drive, a plug-and-play portable SATA drive, so sometimes it needs a few packets before it becomes available. So let's just agree to the terms. And this should all look familiar. We could have also fed the AutoYAS, but we've covered that with prior versions. You can have a look at those just to see how that would play out in terms of using the AutoYAS file. It's actually pretty straightforward. Let's click on Next. And there you can see it's using the B3FS. We'll just go with the defaults for now. Just as we did before. Again, this is all pulling over the wire, which means if we had a smaller footprint for the ISO image, we could have used that as well. Instead of the full 3 gig file, or roughly 3 gig file. Let's use the same password, same settings as before, receive system mail. That looks good. Authentication methods we didn't look at last time. The defaults provided by the YAS installer include etc password, but of course your typical databases can be configured later on. The encryption type is 512 SHA or SHA-512. And when we look at user management, you'll see those long strings in etc shadow. And this should look familiar. And let's say we opt not to install the compiler package on the server. And in terms of booting, as you can see, it won't install into the MBR, but rather into the root partition. It's using B3FS with a sub-volume of boot. So it's really beneath the root file system to begin with. Now, firewall will be enabled, SSH will be blocked. Let's open it so we can connect to it. Kernel dump is enabled in this case. Default system target. Well, we don't want this to be graphical mode. It's going to be a server, so let's just have it go to text mode to save some of the resources, a scarce, precious resource. It's only a gig of memory, and memory is perhaps the resource that's hit the most with respect to overall system performance. So this looks good so far. If there are any other settings that may be of interest, this is the opportunity to do so. Now, these systems that we're installing now are servers. So usually with servers, we impact the IP configuration up front. We don't have it default to DHCP as well as the host name, etc., DNS servers, etc. So it's good if we can make these changes now. But if you're creating an image to be subsequently cloned using your virtualization tools, then maybe the default settings of DHCP are, or those settings are appropriate, or the default is appropriate of DHCP. So it depends on your intent, obviously. Let's see what this is doing. So here are all the components. Just double check, ensure that your hardware looks good. If it looks good, you can go back. Let's see what other settings are of interest to us. Software, kdump, default system target. That all looks good. Firewall SSH. Let's just double check in here. See if there's anything of interest. Enabled, enable SSH. Open the SSH port. That looks good. That looks good. Text mode. Now we've opted to load to text mode, but the installer, because we're installing, the graphical environment is suggesting that we use GUI mode, so you can always disable the GUI environment by not installing it altogether. In the software section, we just disable the X11 environment, the graphical environment, and that would disable it altogether. And each of the components are selected individual, so this plus that, that'll save some space. Let's click on OK. Let's see what the footprint now, we're down to 1.3 roughly, so that's looking slimmer altogether. And let's go ahead and install. Any other changes that we need to make, we can make once the system's up and running. That it is DHCP enabled now enables us to clone it and have, well, using the virtualization tools and have generic settings applied, at least initially, and subsequently allow us flexibility to make changes. So let's just pop back over to this instance. Just document our changes here. So these are our settings, and we're using SUSE Linux 11 64-bit. So SUSE Linux 11 64-bit profile, and that looks good. So then, of course, tie the ISO image. That looks good. Install using HTTP. And for us, that's going to be the following URL, 192.168.75.101, SUSE12. And let's just note, default net settings use DHCP, and this simplifies virtualization cloning, because the settings are generic and are derived from the network at install time, which means subsequently you make changes statically using YAS, etc. So update post, let's say installation or clone using YAS. Let's see where we are. So this is moving pretty well. The network I/O is also pretty fast, so we expect it to move quickly. And also the footprint's about half the size. Actually, less than half the size. The last one was about 3 gigs. This is 1.3, so that reduces the footprint considerably. And that'll come up momentarily. Now it'll be DHCP. We'll have to resolve the IP. That we can assign. We have a space. Let's see from the shell if we can find some stuff that's open. Maybe from this node we'll do an nmap 140 through maybe 142 or something. That'll give us 3 addresses. So this is a space we can use for these SUSE nodes. Let's try 50 as well. 52, 150 through 152. Those are also available, but we'll go with 140 through 142 for our 3 nodes. So find usable IP range for various nodes. And for us, that's just an nmap v. Let's say 75, 140 through 142. So this gives us a range to assign. Now let's see where we are with the installation. At 1 gig footprint, we should be almost wrapping up here. It's looking good. Let's take a look at the details section. That's moving along nicely. Let's pop back over here. So this is using HTTP. Subsequent installs will look at VNC along with SSH, which also uses VNC, and perhaps in conjunction with network-based installations. We'll do it from the perspective of the SUSE desktop. Let's see what's happening here. 80-something%. This is looking good. So, installing SUSE has traditionally been a clean, straightforward process because YAST, the setup tool, has been from the get-go a slick tool, a well-thought-out, well-designed tool. So it streamlines everything. It makes it very easy to configure the installer, the installation process, and everything is presented in a logical, clean fashion. The packages, the various system settings, etc. That has been the case from the get-go. So that makes SUSE Linux even more attractive to the enterprise because you can be assured that you have clean interfaces. However, because of virtualization's ability to quickly provision systems via cloning, etc., it's less and less of an issue that we follow the traditional install methods using, for example, installers such as YAS, etc. So this is good. Let's see what it does momentarily. There's the installer. Actually, this is the installed boot entry. And this should come up with a prompt. Momentarily, we'll be sure to check that we can log in before making any additional changes to the system. Here's our interface. Never mind the host name that's automatically derived. If config IP address will show that it's dynamically driven. As you can see, it's 26 now, which is one over from the other one. Let's send some packets to 25, which is our other node, and to the gateway, and to our 101 node. That looks good. The host name, again, is automatically derived. So YAST itself functions in both text user interface and GUI modes. So we can make changes to our network settings, committing our 140 as a permanent address momentarily. So this interface should look more than familiar from prior versions. Let's edit our interface, the lone interface. Now this is going to be static now. It's going to be 140. Let's call this Linux CBT SUSE1, a name we've used consistently. And no additional IP addresses for now. And that should update the appropriate files. Of course, there's scripts under the hood that this simply updates. Of course, it has to reload the network services to read these changes. Let's quit. Let's do an IP address. So now we're 75.140. Let's ensure that we can still hit those same nodes. And notice the host name still reflects the old setting. cat etc hosts. And in there, let's see if SUSE1 is there. It is. Let's go ahead and reboot it. Now this TTY is already open. What if we close it and relog in? Because we did mention that the TTYs are updated per instance. Notice there's no reflection there. So let's go ahead and reboot it. So it's still reading the TTY that's available. The traditional TTY isn't rereading the new settings on the fly. So let's reboot it. Make sure that it reflects it accordingly before we make any additional changes. And this is referencing it from somewhere else. So let's take a look. And that's where it's getting it from. So etc host name. Actually, this we can also modify. We don't have to make the change here. We can use YAS. We promote the usage of YAS where possible with SUSE because it is comprehensive. Let's just take a look. So, our services. And there is Linux CBT SUSE1. That looks good. So let's see where else it's picking it up from. And this is where it is, so let's change it here. And that should be more like it now. Let's make sure these are specified as well. 75, 101. Let's have it write this new information. Of course, IP configuration, hostname details, etc. is spread across a number of files, so we just have to find it in the interface. Let's quit. Hostname, reboot it one more time. It reads it there, but the shell still has the old value, so let's just give it one more reboot, and we should be fine. And that looks more like it. Let's just check our IP. 140, that looks good. Let's ensure we can log in as a user Linux CBT. And that definitely looks good. So, we're in business. And as we've mentioned, the other consoles are always available. This is F1, 2, 3, 4, so on and so forth. No GUI is running, so 7's blank. So, with that said, let's move on. Some other configurations, other means of installation, etc.